Okay, welcome everyone. This is the World Congress Information Expectation Sessions. So we're gonna have 4 speakers, Alma, Yao Hui, Ricardo, and me, Yang Lu. So let's first welcome our first presenter, Alma Merton, talk about indeterminacy and imperfect information.
Yes. Hello, everybody. Thank you. I'll just share screen now. Okay. Okay. Well, hello, everybody. A virtual welcome also to all our viewers and listeners, and particularly also a big virtual thank you to the organizers for putting this together in these unusual circumstances. So this joint work with Thomas Lubig from the Richmond Fed, Christian Mattes, formerly Richmond Fed, now at Indiana University, me at the Bundesbank. So given our affiliations, the usual disclaimers apply. This is our personal research and shouldn't reflect any views held by our principals. So the topic is indeterminacy and imperfect information. And so the underlying research agenda is basically, we're thinking here about a standard workhorse model used in particular for analyzing business cycles and monetary policy, namely a linearized rational expectations business cycle model. And there, a well-studied problem is actually to consider, well, if monetary policy is conducted with an interest rate rule, what are the conditions to ensure that that way of policy making engineers a unique equilibrium? This is basically the so-called determinacy question. And as I said, it's under full information, it's well studied. And one of the lessons was that the policy rule should respond to endogenous variables, say inflation, for example, or real activity. And it has to do so with sufficient strength. That is actually known as the Taylor principle. And I'll expand on these things more formally in a minute. So our paper actually comes in and says, well, okay, if the prescription is that policy to ensure a unique equilibrium should respond to, say, inflation with sufficient strength, we guess that means the policymaker should be able to observe inflation or the output gap or other endogenous variables. And now we're asking, well, what happens if the policymaker in real time observes at best only a noisy signal of these variables? So my example is usually going to be inflation, so I'll be referring to that one, but also think about maybe the even deeper measurement problems associated with something like the output gap. And then what we find is a sense of what we kind of call generic indeterminacy, which means that there's always going to be some multiplicity, or in many cases, there's going to be some multiplicity of equilibria. And we get that specifically in an environment where the policy rule, because it cannot respond to actual inflation, tries to respond to optimal estimates of said endogenous variables, for example, inflation. So let me actually, before I expand a little bit on my overview, let me give you a concrete example of the sort of environment we're thinking about. So for now, let's think the real economy is determined independently of monetary policy. So we are not yet considering new Keynesian frictions, which of course is something that we do also in the paper. So this is actually going to be the textbook case of price level determinacy with an interest rate rule, as for example, discussed in Woodford's monograph or Galli's textbook and others. So for now, all that concerns us about the real side of the economy is a given process for the real rate, which we could even call the natural rate in this context. Let's take it to be an AR1. And so inflation matters, for example, for bond pricing. And so the bond pricing, then in the linearized environment, gives rise to a Fisher equation where basically the nominal rate equals the real rate, the nominal rate being IT equals the real rate plus expected inflation. And that nominal rate is also the monetary policy instrument. And let's think of that being set by an interest rate rule, for example, of the Taylor variety, where monetary policy responds to inflation. So let me just collect this environment here. Again, we got the Fisher equation, we got our policy rule, and then the lesson from Taylor's analysis and Woodford and others is, well, a necessary and sufficient condition here for uniqueness of a rational expectations equilibrium that is stable, which means that outcomes don't explode, is actually that phi has to be larger than 1. That is this sufficient strength I was talking about earlier. So then in our paper, we are saying, well, that certainly would require the policymaker to observe inflation what if the policymaker cannot directly observe inflation in real time, but gets to see only this noisy signal ZT, which is, say, for example, inflation plus some IID noise. In contrast, we assume that the public observes, of course, inflation and the real rate, as well as the policy instrument. And so the policymaker, he then forms, he forms his best possible projection of inflation, which is this pi TT, and plugs that into that policy rule. And again, he still adheres to the Taylor principle. And we're asking, okay, what happens now? Do we still have determinacy? And what we actually find is that, there are some optimal, when optimal filtering is going on in the formation of this, projection pi TT, then actually there is some attenuation going on where basically the projection doesn't respond quite as much to inflation as it should to ensure determinacy. So that's what we meant by generic indeterminacy. And all of this happens in linear Gaussian rational expectation models. So there is a lot of related literature. There's literature on the conduct of monetary policy under uncertainty. Let me single out, for example, Swenson and Woodford. They looked at the exact same kind of linear quadratic environments that we are looking at, and they tried to describe the optimal policy, but they didn't really consider very much the possibility of indeterminacy. Indeterminacy has been studied quite a lot in a number of papers, and I'm listing just a few here under full information. There's a big literature on imperfect information, but again, in that literature, usually they assume a minimum state variable representation, which precludes indeterminacy. And for example, my co-authors, they have a related paper, but there again, they don't have full rational expectations. They only have learning going on. So for the main part of this talk, I want to actually bring out the mechanics of our framework in this simple example economy. Whereas in the paper, we also actually then write down a general framework. So you could think of, what if I have a bigger model where I have more than just the Fisher equation? I have inflation determination, as well as output equations, maybe some investment stuff. I have backward looking, I have endogenous state variables going on, stuff that you would, for example, usually put into a new Keynesian model, which is then also our application in the paper. But for today, again, I want to focus mostly on this simple example economy. So again, to remember, this is pretty much what you saw before. So the simple example is characterized. Right now, we don't care about nominal rigidities, no new Keynesian frictions. Think of the real rate or natural rate being given by an exogenous process. And we got this basically optimizing forward-looking behavior of the private sector is summarized by this Fisher equation. And we assume that monetary policy follows an interest rate rule. And now let me just, to elucidate a little bit how this indeterminacy business works already under full information, let me go through a few candidate rules. Like one rule, for example, is what if the interest rate, the policy rate, were to follow some exogenous variable? This is actually an example of what Sargent and Wallace already pointed out, which generates indeterminacy. So how would that work here? Well, if we then combine the policy rule with the Fisher equation, that pins down that expected inflation has to be 0, which is good. And so one possible equilibrium could be that actual inflation is 0. However, that's just a possible equilibrium. There are also many other possible equilibria. Basically, any shock to the inflation process would be consistent with that economy. So this eta, this is going to be a recurring thing. This is actually an endogenous forecast error to inflation, which in this case, for example, would be left unrestricted. Policy would make sure that inflation doesn't have any particular persistence, but we cannot nail the volatility of basically of these high frequency shocks to inflation. Now, of course, there's a remedy. That's what I've been pointing at when in reference to this Taylor principle literature, which is one could augment that rule with a term that responds to inflation. If I then combine the Fisher equation and the policy rate, I get basically an AR1 for the inflation process. And again, we got these endogenous forecast errors showing up. And so in the case that this phi coefficient, so this policy coefficient determines here the persistence of that equilibrium process for inflation. And if that policy coefficient is outside the unit circle, then the only stable rational expectations equilibrium would be that inflation has to be 0 at all times, and these endogenous forecast errors have to be 0 at all times. In contrast, if that policy coefficient was inside the unit circle, then actually any eta generates inflation fluctuations that remain stable. You know, they are bounded, they are not growing, they cannot explode. And they still adhere to the forward-looking Fisher equation, the policy rules. That would be a valid and stable rational expectations equilibrium. So that's the classic problem of determinacy under full information. And we could do the same analysis with a Taylor type rule. So where I don't have this real rate tracking going on, just a little bit more involved here. Maybe let me note that in this case, this is going to be useful going forward. With phi larger than 1, there is a unique stable rational expectations equilibrium that then delivers a mapping from the exogenous real rate to, oh, I'm sorry, wrong button. The exogenous real rate to inflation, and that response coefficient G bar, you know, it's a function of parameters. That G bar is going to come up later also throughout the talk, and just remember this G bar is pinned down by this full information solution. That's all I want to say here about that. So again, we got these two cases. If the policy coefficient is outside the unit circle under full information, that ensures uniqueness. Inside, we got indeterminacy. And as in preparation of what we're going to encounter in the imperfect information case, let me talk a little bit how under full information people have already thought about, if you like, representing that indeterminacy, and we're going to build on that representation also in our imperfect information setting. And the buzzword here is belief shocks. So Lubick and Schorfheide and Farmer et al., they said, look, if this eta, for example, this can be anything, we can actually think of that as regressing it or projecting it onto the fundamental shocks, epsilon t in our case, that was the shock to the exogenous real rate process, and a standardized residual, BT. So gamma B, think of that as the standard deviation of that residual. And so this is something we could do without loss of generality. And the rub here is this residual BT that basically captures changes in these endogenous forecast errors that arise for no fundamental reason at all. And they can occur, so basically if gamma B is different from 0, that's indicative of indeterminacy in the sense that non-fundamental things that basically don't have any inherent role for the economy, suddenly start being a driver for economic outcomes. They are isomorphic to sunspots that shift expectations without any fundamental reason. And for example, Lubick and Schorfheide, they show that, well, you can think of these etas arising just by themselves, or you can think of them being essentially representation of you know, suppose that expectations of future inflation shift, well, then that would feed back that essentially the shock to current inflation has to shift by the scale factor phi. And again, if phi is inside the unit circle, basically a current increase in inflation translates into a shift into inflation expectations, and then the whole chain of events is still stationary if this phi is inside the unit circle. So these belief shocks, they're a potentially interesting thing because there is also quite some evidence that it seems that, for example, in VAR studies, that people end up always finding, look, there is a case for purely expectational shocks driving the economy, and this could be one instance. And there's actually a second form of indeterminacy that can also rise later on in our imperfect information setting, which is, well, I already indicated one form of indeterminacy being gamma B not equal 0, so that these non-fundamental shocks matter. But even for the, you know, but even then there are also multiple possible values for the loading on fundamental and non-fundamental shocks. So even if you think about the shape of impulse responses, there will be multiple shapes possible with the second form of indeterminacy. I guess by now it's about time to talk a little bit about how this now works out in our imperfect information setup. So I'm going to stick into a simple example, and I'm going to be thinking about that Taylor rule, where, you know, ideally inflation would be set proportionally to, the nominal interest rate would ideally be set in proportion to inflation. But now the policymaker he cannot do that ideal thing because he doesn't observe inflation. Instead, he observes only this noisy signal of inflation plus this measurement error. And he says, okay, I'm going to do the next best thing. I want to, I'm going to plug in my projection of inflation of the entire history of everything I've ever seen, which is that Z superscript T. And we're going to be thinking of doing that in an environment where all the shocks are Gaussian. Even these belief shocks are normally distributed. We want to be thinking about ending up in an equilibrium that's time invariant and linear. So basically, the optimal expectations can be represented with a Kalman filter. So it's basically Gaussian linear updating. And so there's this recursive representation that basically there's this, the beliefs that they formed, or the projections that the central bank formed last period about current inflation, and then it's a weighted average between that one and the current signal. And the rub here is, of course, that Kalman gain kappa is going to be a function of the equilibrium dynamics. It's a function of the second moments of inflation, the noise, and potentially also some other determinants of the economy. And so conditional on kappa, everything this is a linear model, but of course, since kappa needs to be consistent with the equilibrium, we've got quite some nonlinearities actually going on in solving this model. Now, these projections are formed and then they are plugged into, in this case, this Taylor type rule, just expressed in terms of projections. And again, from henceforth, I'm always going to be thinking of phi being outside the unit circle. So it feels that the Taylor principle was adhered to with respect to the projections. But as you may already anticipate, the rub is going to be that effectively, what matters is phi times and then the sensitivity to actual inflation. So this Kalman gain is going to come in here. And that's, if this Kalman gain is small enough, then we may be at risk at not having a sufficiently strong response to actual inflation. And again, in the background, we're going to be thinking that the public observes actual inflation, the real rate, and the policy rule. And in this simple example, that actually means that it's as if the public can also observe the central bank's information set, which I got to say is an assumption that we're also going to maintain in the larger setting. So we're gonna be buying into to keep it tractable the notion that information sets are nested. And that actually buys us the following tractability. So here I'm now collecting the linear difference system that arises under this imperfect information setup. And so I'm combining, in the first line, you got the Fisher equation with the policy rule plugged in, and we got the exogenous real rate process. And this is almost like a standard linear rational expectation system, except that we have two kinds of expectations kicking in. The big ET, which is the public's information set that essentially knows everything that's relevant for the economy. And then you got this pi TT, which is the central bank's projection. And given that the public information set is strictly, encompasses the central bank's information set, we can actually appeal to a law of iterated expectations. And so here in this middle part, we can actually condition down the whole system of equations to this common inference, so this basically the smallest common denominator, which happens to be the central bank's information set. And that's a neat feature because, that's a neat feature because, well, for one given information set, we know how to solve that system. And we are solving it there again for the stable saddle path. Because, well, if the actual outcome for inflation is supposed to be stationary, well, then one part of inflation is the projection onto the central bank's information set. That has to be stationary as well. It cannot be that the projection is exploding, whereas the actual thing is not exploding. Why can that not be? Well, because that would be irrational, right? Under rational expectations, if I do a rational expectation projection, the variance of the projected thing has to be smaller than the variance of the actual thing. Neat feature here is so that stable saddle path is going to be characterized by the same mapping between projected inflation and the projected real rate that we obtained under full information. So we know that coefficient already. So this thing, we kind of call it the projection condition. And so this is going to be with us. I'm going to come back to it toward the end because it's going to help us tie down a little bit the space of equilibria. It's just not going to be sufficient to tie it down to a unique equilibrium path. Now, why not? Well, let me show you now this notion of generic indeterminacy. And in principle, you know, because we are tracking these, also we may have to track lag projections of the central bank. So the system will have potentially a lot of endogenous state variables. To make that point here most succinctly, let me go to the case where the natural rate processes IID. Because in that case, I can assume that, well, the central bank is always, last period it was projecting to have zero inflation this period, because it's also projecting that, well, if the natural rate is IID, even with its limited information set, the central bank is going to expect the natural rate to be zero next period. In this case, the inflation projection just boils down to a contemporaneous response to inflation plus noise, which is the sigma. Remember, determinacy would now require that the full sensitivity of the policy rate to inflation is larger than 1, which means the product of phi times kappa pi. But then, you know, in the paper, when we combine that projection condition with some optimal signal extraction, and we can actually show that it implies the exact opposite. So unless there's one particular equilibrium where RT can be perfectly revealed, but then there are also other equilibria possible where that is not the case. And in these equilibria, it's a generic feature that if they exist, then we have phi times kappa pi smaller than 1. So the effective Taylor principle, if you like, is not satisfied. And it is not satisfied for any value of phi, because, well, think about it this way. If the policymaker says, okay, I'm going to be now more aggressive in my policy rule, he tends then to stabilize inflation even more so, but that makes the signal even noisier, right? Because you may see this up here, right? The signal consists of inflation plus noise. If the inflation variance becomes relatively small relative to the noise level, well, then optimal filtering will imply that the sensitivity of the projection to the signal goes towards 0. And so that's basically the mechanism why it's generic. And so this whole reasoning will also extend to a more general case when there is persistence in the natural rate, also to this new Keynesian application that we have. But here we can show it more succinctly. Maybe I'm going to be wrapping up in just about 2 or 3 minutes. Let me just pause here before tying it up, the equilibrium determination, and expand a little bit on that logic of, okay, for determinacy, we need an aggressive response to actual inflation, which we don't get when we have these attenuated optimal projections. And one way to basically remedy that, to at least have determinacy, might be, okay, why don't we just plug in the noisy signal ZT 1-for-1 into the policy rule? That is certainly going to give us a unique equilibrium. However, in that equilibrium, it's also going to have inflation is going to depend 1-for-1 or 1-for-1 with to the measurement error. So actually what we can show is, yes, that's a valid equilibrium, but because of that projection condition and some arguments that have to do with optimal filtering, we can actually show that all the equilibria, the whole set of equilibria that we would get when policy actually responded to these projections, generates an inflation variance that is weakly smaller than the one that we get from that alternative policy rule. So interestingly, usually we think of indeterminacy being a bad thing, but here we got this, well, there is a variance bound on the range of outcomes that can occur under this indeterminacy, which in this case, for example, you might actually be happier to be living in any of these indeterminate equilibria than this one, where you can at least ex ante know exactly what you're going to get. And again, that multiplicity comes from because the optimal projections endogenously attenuate the optimal projections. So finally, in the simple example, so how do equilibria look like? And I have to talk a little bit to close this little bit on some additional restrictions we get from that projection condition. So again, I'm in this case, the Taylor rule, RT is IID. And so basically, my inflation process up here, if I collect all the terms, remember, this is now going to be a stable root. So this is going to be the equilibrium process for inflation. We got some exogenous drivers, and then we got these ETAs. Now, in this particular case, ETA, as before, it's going to be, I can think of as a linear combination of the fundamental shock to the natural rate the fundamental measurement error shock, and potentially some non-fundamental belief shocks. And now we basically need to pick any gammas that are possible, except they need to be such that this projection condition holds. It's basically a restriction on the covariance of inflation with the noisy signal, and the covariance of the natural rate with the noisy signal. That's one nonlinear restriction for 3 parameters. So there's potentially one or many. But for some unfortunate parameters, there may be no solution. One feature of that is it places an upper bound on gamma B. Why? Well, suppose gamma B is like really large. And so then these belief shocks, they take over the variance of inflation, then inflation would become nearly observable. And then there is some logic, which basically means, well, but then inflation has to be equal to the full information outcome, which doesn't have belief shocks. So that would be a contradiction. So there has to be somewhere a bound on this gamma B, which in some special cases, we can also tie it down analytically. And depending on some model details, we may also need a minimum level of the variance of these measurement error shocks. So I think I'm pretty much getting here towards the end. Again, in the paper, we talk about a more general framework. So, generic vectors of backward and forward-looking variables. And we then again show how generically we get this indeterminacy argument. We apply it to a new Keynesian model, which has some backward-looking inflation determination, backward and forward-looking, and we calibrate it to sort of realistic parameters, in particular realistic parameters for the noise processes. And hang on, I just got stuck here. And oh, I'm sorry. It seems that there we go. So here to conclude, what we did is we used the standard criterion for linear rational expectations equilibrium. We're not adding or loosening up the restrictions. The key element of our setup is that the central bank does not perfectly observe what goes on in the public's forward-looking decision process. And that is something that potentially even survives if the public does not know everything that the central bank is doing. What really matters for us is, can the central bank observe exactly the consequences of a belief shock on endogenous variables? If that isn't possible, we think this mechanism would also survive in this more general setup. And then what we get is basically that this optimal filtering, formally this Kalman filtering that we do, it only adds stable variables. So it doesn't, and then to the extent that we are concerned only with stable outcomes, it adds possibilities for equilibria. And so in that sense, we get generic indeterminacy. So finally, informational frictions can give room for non-fundamental shocks to drive outcomes. That might be an interesting feature of this. And the determinacy conditions will really depend on details of the information structure. So we cannot just say, we learned something from, for example, the Taylor principle under full information, which then guarantees us determinacy under imperfect information. No, we need to study the joint problem, and the consistency of beliefs between agents, particularly the public and the central bank, places some bound on these non-fundamental fluctuations, and that is a result that we didn't have under full information. That pretty much precludes my prepared comments. Guys, if you have any questions or something, I'd like to open the floor here.
I think we have question for one. We have time for one question, if any one of you have.
I would actually have one quick one.
Okay.
Well, it's actually two short ones. One, if I'm right in thinking that this pervasive sort of issue that you come up with would be even stronger if you assume that the private sector fed off the same sort of noise, and instead of observing, so would it become an even bigger problem if the private sector also faced imperfect information? And the second one, real quick, would it make a big difference if instead of assuming that there is noise in the observation of inflation, you'd have noise in the observation of the natural rate of interest, which is not loaded by that phi parameter?
Yep. So on the first one, what we definitely need, we need some asymmetry between the central bank, and particularly that the central bank knows something that the central bank lacks knowledge of something that the private sector does know. If this was purely symmetric, then basically the private sector's decisions are based on the same set of shocks that the central bank can observe. And so then this goes away. And to your second question, Yes, I mean, what's really key here is that the central bank gets a signal about an endogenous variable. So as long as the real rate is an exogenous variable, yes, you may also get interesting indeterminacy, but you don't get that bound on the belief shocks.
Thanks.
Thank you.
Okay, so we will defer more discussions later. So now I think let's welcome Yao Wei to present inflation expectations of households and an upgrading channel. Yao Wei, the floor is yours.
All right, can you see my screen? Is it okay? Yeah.
Yes.
Yeah, okay, that's great. Okay, hi everyone. A very warm welcome to our session. So I'm Yao Wei from the National University of Singapore, and it's a joint work with Sumit Agawa, also from NUS, and Chang Chong Song from Singapore Management University. So in this particular paper, what we're going to do is explore the inflation expectations of households and the upgrading channel. So allow me to start by motivating this paper. Why are we doing this paper? So now what's going to happen is this. In recent years, there has been much interest in the study of households' inflation expectations. From Janet Yellen to Ben Bernanke, there's been a lot of suggestions to make use of inflation expectations to stimulate growth. And this is particularly relevant in a low interest rate environment. However, there's been no consensus with regard to the drivers of households' inflation expectations. So recent studies has identified several factors that could influence households' inflation expectations. This includes the price and perceptions of inflation, shopping experience, media, as well as the understanding of economic policies. Now, in this paper, what we're going to do is to focus primarily on the personal experiences of households and study how the changes in the consumption bundle of goods could influence inflation expectations. We call this the upgrading channel. Now, while much work has been done documenting the effect of quality change on households' actual inflation rate, there's in fact little evidence studying the effect of quality change on households' inflation expectations. So in this paper, we hope to advance the literature in this area by focusing on the change in inflation expectations. To do so, we're going to combine several administrative data and a survey experiment to evaluate the role of lifestyle changes in influencing households' inflation expectations in Singapore. Now, lifestyle changes, together with economic development for the past decades, have contributed to the changing basket of goods for consumers. Moreover, items that were not previously available, like smartphones, are now considered to be necessities. So as the standard of living increased for the median households, the inflation expectations could increase as well. So this is what we call the upgrading channel. So for the same product category, households could shift their so-called bundle of goods, their spending, to brands of higher quality. In doing so, they end up with higher inflation expectations. So let me give you some simple intuition. So suppose a household's inflation expectations is a weighted average of two types of goods, high quality and low quality. And this comes across two time periods, period 0 and period 1. The price of the high quality good in period 0 and period 1 is P high 0 and P high 1. The price of a low quality good in period 0 and period 1 is P low 0 and P low 1. And now W0 and W1 refers to the weight of the high quality good in period 0 and period 1. So intuitively, an increase in inflation expectations can be due to two things. Number one, an increase in the price of the goods from period 0 to period 1, or an increase in the weights from W0 to W1. So two possible cases. So we define upgrading as an increase in weights towards better quality goods, i.e. when W1 increases from W0. So allow me now to present a roadmap for the next 20 minutes or so. In essence, I hope to achieve two things. Number one, I would like to establish that it's upgrading in Singapore. So to show that households are upgrading across different categories of goods, we're going to examine a transaction level credit card data from a bank in Singapore. Next, to show that households are upgrading within a specific category of goods, we're going to exploit the Nielsen HomeScan panel. I'll elaborate more on the data in the next few slides. Number 2, I want to establish that there is a relationship between upgrading and inflation expectations. To do so, I'm going to make use of a survey experiment that we conducted and to link our survey experiment with the Nielsen HomeScan panel. So this is what I'm going to do for the next part ahead. So firstly, we have a first look at how Singaporeans are upgrading across different categories of goods. Here, we use a unique panel data set that's obtained from a leading bank in Singapore. So the bank has about more than 4 million customers in Singapore, which is approximately 80% of Singapore's population. Our sample data contains a random representative sample of more than 180,000 unique individuals during 2 time periods, 2011 and 2016. For each individual in our sample, we do have transaction level data about their credit card spending, involving the date, amount spent, merchant name, and goods category. We then divide the households into 5 different quintiles and find a change in their spending across the different categories. So what do we see? Across categories of goods, we see that the increase in credit card spending differs across quintiles. For luxury goods like watches and jewelry, the increase in spending is largest in the second quintile, followed by the third quintile. For entertainment, the increase is largest in the first quintile, followed by the second quintile. This suggests that for households in the lower quintiles, there is an increase in the spending towards more luxury products like watches and jewelry, as well as entertainment. In comparison, for households in the higher quintiles, there's an increase in spending across clothing and restaurants. Consequently, we can see that across times, households in different quintiles change their basket of goods. Next, allow me to turn to a specific category of goods, groceries. So to study consumers' choice of grocery goods in detail, we're going to use a transaction level data of 900 households between 2016 to 2017. The panel has large coverage and is demographically and geographically representative of Singaporean households. Essentially, this panel seeks to track household purchases of all the grocery goods from all the retail outlets in Singapore. Using a barcode scanning device, households in the panel electronically record their purchases. And we also have information of each household's demographics, such as their race, household size, income, age, and postal code. For each transaction, we also know the name, shop name, category, brand of goods, as well as the price, weight, and the quantity of goods purchased. Now, let's take a look at the summary stats now. Okay, so as mentioned, there are 900 households. On average, they spend around $122, and the majority of them have a household size between 1 to 4. The household income looks quite well distributed, with more seniors, and with 80% Chinese and 80% respondents staying in the public housing. And that's quite representative of Singapore's population. So using this data, what we can do, we are able to create a monthly upgrading index for each household. So for each category of goods that we have, we're going to group the brands into 10 different bins based on the price per weight. Here, 1 refers to the lowest price per weight, while 10 refers to the most expensive good. This is an indication and a proxy for the quality of the good and be used widely in the literature as well. Once we have the quality index for each good, we can then compute each household's quality of goods index. Here, QIT refers to the household ICE quality index at time period T. XJT refers to the quality of good J consumed by household I at time period T, and then sum it across the number of goods. The household quality index should lie between 1 to 10. If a household purchased all the goods in the lowest bins for all categories, they will obtain an index of 1. Conversely, if the household purchased all the goods in the highest bin for all categories, they obtain an index of 10. So we now present the changes in the household's quality index during the 24 months. The graph in the top left-hand corner presents the overall change in the quality index for all households. We find that overall, there's an increase in index as households switch to better quality goods across time. And this increase in the quality index is also consistent across housing types, okay, public housing and non-public housing, as well as the household income. So we do see a trend of increase in quality index across time by households. Okay, finally, let's turn to our survey. So to pin down the upgrading channel, we conducted a personal interview survey face-to-face across Singapore. So we have surveyors walking around between March to July 2019, and was conducted at different places. These include shopping malls, food courts, and train stations. Each survey takes around 15 minutes, and each respondent is given 20 Singapore dollars as a form of compensation for their time. In our survey, there are 3 sections. Firstly, we obtain information of their demographics and individual economic circumstances. For example, their age, gender, race, housing type, personal financial status, as well as financial literacy. The second section builds on a New York Fed survey of consumers' expectations. We collected a whole range of households' expectations of economy, including their inflation expectations. Finally, we conducted our survey experiment. So our survey experiment follows several studies in the literature. Firstly, we elicit the subject's inflation expectations at the start of the survey. Our subject will give a specific number, which constitute their prior belief. We then provide the subject with information that's related to different treatment groups. Finally, we ask them about their inflation expectations again. So for this survey, we randomly assign households to 3 different treatment arms. We introduced something that most Singaporeans can relate to: ice cream. In particular, the brands Walls and Häagen-Dazs. So while Walls cater to the mass market, Häagen-Dazs is sort of a super premium brand. And since Walls and Häagen-Dazs can be considered to be a normal good and luxury good respectively, we want to see how the subjects update their inflation expectations given information about different types of goods. In 2009, 1.5 litre of Walls ice cream cost $5, while 1 pint of Häagen-Dazs cost $12. In 2019, both ice creams increased by approximately 20% to $6 and $14.45 respectively. So our experimental design focused on how respondents react to price changes or different types of goods. As you can see in the first row, we provide the price of Walls in 2009 for the entire sample. We then try to vary the price information in 2019 by showing them prices or different goods. So for T1, households were given prices of Walls. It's our control group. For T2, households were given prices of Häagen-Dazs. For T3, both Walls and Häagen-Dazs were given. So by varying the availability of price information in 2019, our objective is to study how households respond to prices of different goods. So let's take a look at our summary stats now. In all, we have about 1036 respondents, and the demographics are a good representation of Singapore's population. Now, I would not want to go through the summary stats in detail. Rather, I want to talk about 2 things. Firstly, it's evident from the p-values that our random assignment of subjects does create balanced treatment and control groups. Except for one indicator, possibly. negative outlook. Nonetheless, the fact that 1 out of 15 variables is significant at a 10% level is expected under random assignment. Secondly, we find that households in Singapore have significantly higher inflation expectations as compared to the actual inflation rate. Among the treatment groups, the pre-treatment inflation expectations are between 6.6% to 8.17%. In comparison, Singapore's actual inflation rate in 2019 was 0.6%. So there could be many possible reasons for this divergence. One possible reason could be due to the upgrading channel. So we turn to our survey experiment for further investigation. Right here, we present the pre-treatment and post-treatment inflation expectations for all the treatment groups, alongside the 90% confidence interval. It's evident that the provision of information has different effects on the inflation expectations of subjects in different treatment groups. For T1, there's a fall in inflation expectations relative to the pre-treatment levels. That's our control group. In comparison, the increase in inflation expectations for T2. Finally, the fall in expectations in T3 is smaller than that in T1. So we do see some effects, okay, by looking at the different inflation expectations, pre and post treatment. More formally, allow me to show the treatment effects through the following regression. So delta pi I is a change in inflation expectations of individual I due to the treatment. T2 is an indicator for treatment 2. T3 is an indicator for treatment 3. Xi are the controls we mentioned earlier. These include things as the gender and age and so forth. Eta D is the district level fixed effect, is on where they stay. Eta E is the enumerator fixed effect, this is a surveyor. While eta M is a surveyman fixed effect. So let's have a quick look at the results now. So in column 1, we included the controls, but not fixed effects. In column 2, we included both controls and fixed effects. So both columns indicated that the treatment effects on inflation expectations are significant. From column 2, we can see that subjects in T2 reported an increase in expectations of 505 basis points as compared to T1. This suggests that solely providing price information of higher quality goods in 2019 and not the lower quality product will result in higher inflation expectations. In comparison, subjects in T3 reported an increase in expectations of 162 basis points. So therefore, providing additional information of the higher quality product in 2019 together with the lower quality product will also lead to an increase in inflation expectations. In addition, from the Watt test, we can find that the change in expectations in T2 and T3 are significantly different. So now, the difference between T2 and T3 do show that inflation expectations will increase less when the information of higher and lower quality products are made available. So T2 and T3 differ, and we want to quantify this extent to which the inflation expectations are affected by the high quality product. To do so, we compute something called an upgrading alpha. The upgrading alpha is defined as a ratio of a difference between the change in expectation of T3 and T1 and the difference between the change in expectations of T2 and T1. So intuitively, the upgrading alpha will measure the weight that respondents place on the additional price information on the luxury good, informing inflation expectations. The larger the value of the upgrading alpha, more emphasis is being placed on the luxury good, in this case, Häagen-Dazs in 2019. So the upgrading alpha should be between 0 to 1. When the upgrading alpha is equal to 0, it suggests that there's no difference at all between T3 and T1. That is, the respondents in T3 ignore the additional information of Haagen-Dazs in 2019. When the upgrading alpha is equal to 1, it suggests that there is no difference between T3 and T2. In this case, the respondents in T3 only focused on the additional information of Haagen-Dazs in 2019 and not Waltz. So based on our results, we compute the upgrading alpha to be 0.32. So in the formation of the inflation expectations, household does allocate 32% of the weight on the price of Haagen-Dazs in 2019. Okay, so we've gone through the main results. So to examine households' differential response to different treatments, what I'm going to do as well is to analyze the heterogeneous treatment effects through the following ORS regression. So everything is the same as before, except for ZI. So ZI is an indicator variable if the respondent does shop at least once per week. So for frequent shoppers, we estimated that the upgrading alpha to be 0.56. For non-frequent shoppers, the upgrading alpha is 0.12. So this means that in forming the inflation expectations, the weightage on the price information of the higher quality product does play a larger role for frequent shoppers. Okay. Finally, what we're going to do is to study the upgrading channel by mapping our survey with the personal shopping experience from a Nielsen home scan panel. Here, we examine the relationship between the changes in the household quality index and the household's inflation expectations at a group level. Unfortunately, we cannot map our survey subjects and Nielsen subject levels at the individual level because they're from different data sets. So what we can do is to link them at the group level. So households are being categorized in the same group if there's common characteristics: household income, postal code, household size, race, and frequency of shopping. So this is based on the assumption that households in Nielsen home scan panel and our survey is representative to the households in each group. In all, we can map around 195 groups that are common in both samples. We then run the following regression. Pi j refers to the average inflation expectations in each group j. Uj refers to an upgrading index, which we could define them as a difference between the average household quality index for the last 3 months and first 3 months. The covariates on gamma j are demographics and personal characteristics that we used to map them earlier. And eta d is a district level fixed effect. So this means that an increase in upgrading index by 1 unit would imply that the household has purchased the brands of better quality goods by 1 bin for this entire bundle. So let's have a quick look at the results now. So column 1 reports the results without any controls and fixed effects. Column 2 reports the results with both controls and fixed effects. And both estimates do show a positive relationship. We find that an increase in the upgrading index by 1 unit corresponds to an increase in the inflation expectations by 65 basis points in column 1 and 52 basis points in column 2. This shows that households that have upgraded the better quality products indeed reported higher inflation expectations. This further supports our hypothesis for the upgrading channel. So in all, okay, it's the last slide, right? Okay. So in all, we do show, and our findings do highlight the relationship between personal experience, product variety, and inflation expectations. Consequently, our findings do have some potential implications for policymakers. To reduce inflation expectations, for instance, policymakers could try to increase the availability of goods. And this is especially true at the lower end of the quality spectrum. To reduce such costs for households, we could provide more information on affordable goods. And this could be in the form of newspapers, notice boards in estates, or even handphone apps. So in some, quality matters, and it's something that we should not neglect whenever we study inflation expectations. All right, that's it. I'm done. Thank you for your time.
All
Thank
right,
you.
we're right on time. So 5 minutes for question and answer. Alma.
If I may.
Yes.
On this, the middle bullet on the policy advice that increasing the availability of goods would help to reduce inflation expectations. So help me, how does it tie into the results? You had results that showed that people that end up purchasing the higher quality goods increase their inflation expectations. Did they do that because they didn't find the other ones unavailable?
Yeah, so
or?
Right now, because we actually remove the lower quality products, so as we move up the quality spectrum, for example, by removing the lower quality products, people end up with higher inflation expectations. So in this context,
so that's in the information treatment, or?
Yeah, for the information treatment, as well as. So the key point is that we shouldn't remove away all the low quality products. Put it there for people to actually consume and so forth. Yeah, that's the key point. Yeah, because
so maybe as a brief follow-up, maybe also more broadly, so you had some evidence which was about an information treatment, but then in your purchase data you have information on what people actually purchased.
That's right.
So this availability of goods, is it really that people were just oblivious to the price of the lower quality goods because they didn't look at them, or because they weren't available? I guess that's what I'm currently struggling with. Did they not buy them? I mean, when they didn't buy them, is that because they didn't see them, or because they chose for some other reasons to only look at the higher ones? So is this upgrading channel information, or is it availability?
Okay, so from a Nielsen home scan panel, we cannot identify that channel. That's why we had to actually create the so-called survey experiment to test out the channel precisely.
Okay.
So for the Nielsen home scan panel, we just managed to see that people actually are upgrading. So we find evidence that people are upgrading in that sense. But we cannot pin down, is it information story, that's what you highlighted, or is it some other stories? That's why we came up with the survey experiment to try to test this hypothesis by giving them different information to see what kind of results they report. So this is what I try to do by putting them together. Yeah.
Cool, thank you.
Okay, thank you. Thank you for your questions.
So I also want to ask a clarification question. So just make sure I understand your survey. So your survey has this evidence that with the same price increase, 20%, people will be more affected by the lower quality goods price change. Is that right?
That's right.
Okay, so that's why you're saying, based on the survey evidence, you should basically expand the lower end of the spectrum in terms of the food category or goods category, so that. So, but this is like because so my question is, do you want? So is this like you're giving people better information, or you want people to, like, the actual inflation is 20%, you want people to form a lower than 20% inflation expectation? So I'm just trying to get the sense, like, when you say it is better, what do you mean by you mean what the policymaker want a lower expectation, or the policymaker want the people have a good idea about what exactly the inflation is?
Okay, thank you for your question. So the experiment purpose is just to show that given different type of information, for example, we have an effect on the inflation expectations. That's our key objective for this survey experiment. So the objective is to just tell people that if you look at different kind of goods, exposure to different prices, exposure to different type of goods, you end up with different kind of expectations. That's the purpose for this experiment. But in terms of policy implications, it will depend on the government's objective. So because in Singapore, there's this perception of very high inflation expectations, maybe in Hong Kong too, or in some other places as well. But this is not due to the type of goods available. It's due primarily to the exposure of better quality goods and this misperception that people does have. And we hope to correct this misperception by giving people more type of goods being available and exposed to more type of prices and so forth. So we believe that this is an issue of perception versus actual inflation goods. That's why I talk about the upgrading channel, essentially.
I see. Okay, it answered my question. Thank you.
Okay, thank you so much for the question. Thank you.
Any Ricardo? No?
Well, no, actually, just a simple clarification question. Just was trying to think out in my mind how the process worked for these respondents. So your conjecture, what you're testing, is that if you ask me about inflation, I would compare the price of ice cream I bought today versus the price of ice cream I bought yesterday, without accounting for the fact that today I bought Häagen-Dazs and yesterday I bought Walls. Or it's more about the perception of, so do you control for what they buy, or do you focus more on what they perceive is out there?
Or thank you for the question, Ricardo. Okay, so in our survey experiment, what we do is we actually control what they perceive, because in our so-called Nielsen data and all the data we get, we see people buying different types of things, but we cannot pin down the perception essentially. That's why it came up with this survey experiment, to pin down this perception, because we do see people changing their expectations, their prices, but we don't know why is it so. So we hope to shed some light, a bit of light, in terms of telling us what caused this to happen.
Thanks a lot.
Thanks for the question. Thank you.
All right, time is perfect. So next, let's welcome Ricardo to present us about individual experience and inflation expectations. Ricardo.
Yes, I'm sharing my screen. Try and get the list. All right. So thanks a lot for putting this paper on the program virtually. And this is literally very preliminary and complete. We hope we had more time to work on this. So you're gonna see literally where we're at with this. And this is joint work with Dario Bonciani, also at the Bank of England, and Silvia Sarpietto is a great PhD candidate at UCL, who's gonna be on the market next year. And as usual, the usual disclaimer applies. These are our views and not those of the Bank of England or any of its policy committees. So let me get going with the motivation, which actually follows quite nicely from the previous presentation. And so the starting point is very simple. Individual experiences have been found to shape inflation expectations. There's been a lot of focus on that over the last few years. Possibly the most famous paper is this one by Malmendier and Nagel, but then there were others. And we're gonna follow up on that by defining experience in a very specific way, in a much narrower way, if you want. And in particular, we're gonna ask people, or we're gonna have information about what experiences, by which we mean good prices, were important for their perception of inflation, where perception here basically mean they're a backcast for inflation. So, and then of course, we're gonna focus, most of the empirical part of the paper is going to be about people tell us directly how their experience impacted their perception. Then we ask ourselves, do these experiences matter when study the relationship between perceptions and expectations? So that's what most of our empirical analysis is going to be about. And then the next step, which is largely incomplete at the moment and underway, is what are the implications for policy, or indeed for the macroeconomic environment at large. And by that we mean, by studying the inflation expectation process, of course, we're getting at a key mechanism for the transmission of monetary policy and other policies as well. And so we would like to embed that into a model and see what the effects are. In particular, speaks to a fairly old debate in the monetary policy literature about whether central banks should care more about core inflation or headline inflation. As with everything else on these slides, the references to the literature are incomplete, but hopefully at least it will do some justice to the many people that thought about these issues. And in particular, there's two arguments for in favor of paying a lot of attention to core inflation. One is statistical in nature, and it is core inflation basically excludes food and energy prices from the CPI index. So those prices are known to be very volatile. So on purely statistical grounds, by looking at core inflation, you have a better predictor of future inflation, at least in some cases. So Blinder and Rice find it for the US. And then there's also what we could call supply considerations. That is to say, food and energy prices are very flexible, very volatile. So there's not much scope for monetary policy to affect them. That's all well and good on statistical grounds. But then there's a recent literature that shows that inflation in these sectors are very important in shaping overall inflation expectations for agents. And then the question is, even though food and energy prices might not play a huge role in the overall CPI index, and especially when projecting it forward because of their volatility, they can have important impact on inflation expectations. So it might be worth keeping an eye on them. And I think the paper closest to ours is D'Acunto et al. That uses scanner data and argues that monetary policy should pay close attention to food and energy prices because of their impact on expectation. And so what we're doing speaks to this literature across few different angles. So as I just mentioned, it speaks to the core versus headline inflation debate. It speaks to the literature on how experiences shape inflation perception, and we just heard a presentation that speaks to that as well. And here, of course, we have a few papers that speak about how lifetime experiences are important. We could call it country-specific experiences are important. We're going to have a much narrower meaning to what experiences mean, but I'm going to be more precise later on. And we also like to think we contribute something to a strand of the literature that uses surveys not so much or not only to measure expectations, but to get more at the bottom of how agents think about and how they respond to different shocks. For instance, this paper by Andre et al. Study how people understand effectively macroeconomic shocks and how they respond to those. Whereas Michelacci and Pacello use the same survey we do to study how expectations of inflation and unemployment could vary with each other. But as I said, probably the paper that is closest to ours is D'Acunto et al. Let me say just now, I'm going to be more precise later. We don't have a scanner data, but so we sort of complement that, if you want, in the sense that we have information directly from the agents about what matter for them. So let me get going. So what we're aiming for is to study, in particular, how the relationship between inflation perceptions and inflation expectations varies with what matters to people. So in other words, what our empirical specification is going to be about is, if I think that food prices are very important to me, do my inflation expectation relate to my inflation perceptions in a different way relative to someone else who doesn't care about food prices at all? This is what we're going to get at. And then we're going to study how this matters for policy, and that's underway. So the data we use is the Bank of England TNS inflation attitude surveys, which asks agents specifically to which extent their personal experience of the change in the price of various good types affect their perception of overall inflation. And as I said, this complements a lot of literature on using very detailed sort of scanner data and good type data, which of course has a lot of benefits. Here we sort of, approach it from a different perspective, and we just go to agents and ask themselves what is important to them. So we know from that literature that, for instance, the shopping frequencies, it turns out to be very important for inflation expectation formation. Here we get this sort of summary statistic because we ask agents what matters for them. So it might be that for some of them it's shopping frequency, for others it's because they spend a lot of their expenditure on a particular good. We just get this sort of summary statistic and we go from there. And this in particular is the question that we're gonna be focusing on. This question was asked in 4 different waves of this survey. So that's what our sample is going to be about. So we have data from 2008, 2010, 2011, and 2013. And it asked, when you said that prices had changed over the last year, how important were the following things in getting to that answer? And here it speaks about experiences. That's why we call it experience. Of course, it's a different experience relative to, some people would call experience if people lived through the high inflation of the 70s or something. This is a much narrower understanding of what experience is about. And we have these different categories: food and drink, clothing, transportation, household, inflation in the media, VAT changes in the media. In the UK, there were VAT changes over that period, and other factors. For this particular presentation, we're going to mostly focus on food and energy, but we have all that data. And then for each respondent, we also have the inflation perception. So they basically ask them what you perceive the inflation to be over the last 12 months. And of course, as we all know, while for professional forecasters, there's very little dispersion in the response to this kind of questions. For consumers, there is a significant amount of variation. And also they ask about expectations at 1 and 2 year horizons. And then we have a lot of personal characteristics that we're going to be controlling for in our regressions. Okay, so let me start giving you a sense of the variation here. Of course, with all this data, you can cut them along all kinds of different dimensions, and I'm gonna get into more, quantitative analysis in just one slide or two. But here, just to give a sense, let me show you this histogram here, which shows the responses cut across education levels and sex. So here, the bars represent the importance of each of these item types on the inflation perception. You can obviously see some cross-sectional variation. You can also see there's sort of like a pretty consistent ranking. So food tends to rank very high, and energy also ranks pretty much always in the top 3 across these different categories that we have here. So, the takeaway here is like some good categories tend to be very important. And they also tend to be those that refer to volatile components of the CPI basket that we tend to, not include in definitions of core inflation. But there's also important heterogeneity across agents. And we do that a bit more formally here by estimating an ordered probit. It's an ordered probit because when asked about the importance of a certain good category, it's not a yes or no question, but there are 4 possible answers, which is to say that, say, food is very important, fairly important, not very important, or not important at all. So we use this order probit, and of course, these coefficients are not directly interpretable as probabilities. I'm going to get to that in a second. The takeaway here is like, even controlling for all the kind of controls that we have and doing it a bit more systematically, there's obviously heterogeneity across agent characteristics. So different agents tend to attach different levels of importance to different good types. And just to give you a sense for how this works, let me focus again for a second on education, and let me focus on food. So these are predicted probabilities from the probit that for which I showed the estimates just now. But these are interpretable as probabilities. And the way to think about this is when the education indicator increases by 1 unit. So let's say we go from college to, from high school to college or something. The probability of food being reported as not being very important increases, as well as the probability of food being not very important or fairly important. What falls is the probability of food being very important. So this gives a sense of, more educated people tend to attach less importance to food prices. And of course here for clothing, there's a fairly similar pattern. For the others, they're not significant for education. They're more significant along other dimensions. But that's not too important. This is again to stress that there is significant variations across demographics. And this is just, due diligence to show that when we look at annual inflation in the UK, the pattern is more or less what you all probably have in mind, in the sense that the energy and food components tend to be less correlated and more variable than aggregate CPI. Right? This is pretty much the only takeaway of this. So this is to say that lots of people in our sample tend to attach a lot of importance to these components that are very volatile. So let's get to the main empirical specification here. And this is a regression that might remind you of some of the sort of Kalman filter type regressions that have been estimated in the literature, trying to relate expectations with perceptions. But let me go over it step by step. So on the left-hand side, we have the inflation expectation for agent I between time t and time t+1, where time is measured in years. So this is 1 year ahead expectation. The right-hand side, of course, we have a constant that we have the perception for the same agent for inflation over the previous 12 months. Then let me skip to the next line for a second. We have the dummies that control for the importance of food and energy prices. And so here we do it for different categories. So good X is the good category. It could be food, it could be energy, it could be all the other categories that I showed you before. And we include a dummy for each of them, whether agents said that good type was very important, fairly important, not very important, or not important at all. Then, of course, we also want to control for aggregate actual CPI inflation over the previous 12 months as sort of like the key aggregate macroeconomic control. And then we use all our individual controls that we have. But the key variable here is this one here, is this interaction term here that gets at whether people that say, let's focus on food for the purpose of this. People that say that food is very important to them to form their inflation perceptions, does them make their inflation expectations more correlated with their perceptions or not? Which another way of looking at that is to say, would they put more weight on their perceptions, or would they put more weight on some kind of news about the future that will make them have inflation expectations that differ from their perception? This interaction term is really going to be the key to our specification. And we could rerun this same regression, and indeed we do, for 2 year ahead expectation instead of 1 year ahead. The big picture is the same. We would have fewer observations, and for the purpose of this presentation, we focus on the 1 year ahead. All right, and this is the first set of results. In the first column, so here I drop all the I indices for individuals, just to save on notation. And so here, of course, in the first column, you can kind of see that inflation expectations clearly relate to perceptions as well as to past inflation. And here we have food as a categorical variable. The second column, we have food as a dummy variable. So here, food is a variable that takes values 1, 2, 3, and 4, depending on the importance. Here we have dummies instead. You know, it doesn't really matter for what we're doing. In passing here, we find, which I think, you know, is fairly common, that agents that attach a lot of weight to food prices tend to have higher inflation expectations on average. But, you know, in a way, this is not the key focus of our analysis. What really matters for us is what you have on the third column, where we introduce the interaction term. And what we find is, like, people that think that food is very important to them to form their inflation perceptions also tend to attach more weight to their perceptions relative, you know, to news, if you want, when forming their inflation expectation. So another way we refer to this, maybe a bit more, you know, loosely speaking, is to say that their inflation expectations are more sluggish. So this is true for people that say that food is very important. That's also true, you can see it here in the last two columns, for people that report energy to be very important to them, and for people that report both food and energy to be very important to them. So these are the, you know, most volatile component. Of course, we could do this for all the categories we have. But, you know, the pattern seems to be that people that attach a lot of importance to these good types also tend to rely a lot on their perceptions when forming their expectations. And just to give you a sense of what we're talking about, you know, lots of people tend to attach a lot of weight, or to report that they attach a lot of weight to food and energy prices. So it's over 40% the share of people that say that food and energy are both very important to them. So it's not small subsection of the population. So these are the main sort of takeaways from our empirical analysis here. And of course, one challenge we face is that what we have does not, the data we have does not have a panel structure. It's a repeated cross-section. So we have no way to directly control for individual characteristics the way we could do with, like, fixed effects or something like that. What we can do though is to use you know, clustering, and in particular we use this fuzzy C-means algorithm of Louis Melkanji and Pilosov, a very recent paper that allows us to control for unobserved heterogeneity. In particular, we can jointly estimate the cluster coefficients and the individual weights of individuals belonging to each of the cluster. And what's new with this is, like, you don't necessarily, you know, you just, it's a probabilistic statement about whether one individual belongs to one cluster or the other. The main takeaway, though, from a macro perspective here, is that our results seem to confirm so far. You know, there are a bunch of tuning parameters that we are getting to terms with this procedure. But so far, what we have suggested our main results are robust to controlling for unobserved heterogeneity this way. So all in all, it turns out that agents that attach a lot of importance to food and energy prices display higher correlation between perceptions and expectations. And this, you know, in a way, in spite of the fact that food and energy prices are very volatile. So while they are very volatile, they can have long-lasting effects on expectations once they, quote unquote, seep through their perception. And so this is something that is potentially very important for for any policy for which inflation expectations might matter, and of course, a monetary policy is one of those. So let's get to the model, and at the moment we have the full information version of the model. As you can probably tell already, that's not enough to get at the very bottom of these questions, and that's what we're working on right now. But hopefully it will give you a sense for where we're going to and how the mechanism works. So we need a model with heterogeneous agents, not necessarily atomistic agents, but we need groups of agents that attach different weights to different good types. And that is to basically have different inflation experiences, or different inflation in their bundles, basically. And also that would translate into different expectations for aggregate CPI. Now, we like to think that we have made good progress towards the first two, so having different agents and different inflation, different consumption bundles, and hence inflation across them. For the last one, we need informational frictions that we don't have just yet, and we are working towards. So let me get a bit more specific about how we got to modeling this. At the moment, we have two household types that differ by their labor productivity. There's a high productivity type and a lower productivity type. We assume for simplicity that the low probability type is hand to mouth. And the reason we do so is kind of technical at the moment, because their inflation expectations for their specific consumption bundles are different. We wouldn't know necessarily who the marginal investor, a saver, is at each point in time. So, that's an interesting question, but it would distract us from the main goal here. So for the time being, we assume that the low type is hand to mouth. And we also assume that—
Sorry to interrupt. So you're already 25 minutes, so you may need the next 5 Q&A to summarize your model, Ricardo.
Yes, I'll go very quickly. Okay. Basically, thanks for letting me know. We assume non-homothetic preferences, and this is the key, basically, to have that the low type has different consumption bundle and has hence different inflation and hence different inflation experiences than the high type. Okay, or the supply side of the economy is a standard New Keynesian, very simple model. So as I'm late here, let me just say that the key takeaway here is like with these kind of models, we have all kinds of different inflation indices by agent type and overall inflation. So we have the different agents have different inflation in bundles, different levels. They experience different levels of inflation. The next step would be to explain why that translates into different inflation expectations at the aggregate level. And for that, we need some form of friction that we are working on. This pretty much I have mentioned. So let me leave you with the conclusion, and I'm happy to take questions in the 2-3 minutes I have. So the main conclusion is like we sort of complement the great work that people have done looking at specific consumption bundles and what people consume. We instead sort of exploit a survey in which people tell us what matters to them. So it's a slightly different take on that. And then we find that people that attach more weight to volatile CPI components tend to have more sluggish inflation expectations, and we are studying how that matters for the macroeconomic environment at large. Thanks.
Okay, so we have 2 minutes for question and answer. Yeah.
Maybe, yeah, Ricardo, super interesting, great. Just in the interest of time, just to make sure I got this correctly, you referred, I think, to some regressions as being Kalman filtering-like regressions, right? You had these deviations of, say, somebody says energy prices are important for me, and then you measure how his current inflation perception differs from the average, and you show that that actually then also is a significant determinant of that person's future inflation expectation. That result is essentially showing, it's just confirming that when this guy said this is important to me, it's showing yes, it is, right? Or is there something even more?
No,
Which, by the way, would be good because could be that somebody says it's important to me, and then it pans out to be not, right?
Yes. No, we're studying that. So we're trying to look at how the inflation perceptions and expectations of a guy that says food is important to me relates to food inflation as opposed to headline inflation. Yeah, we're looking.
Right. But his expectation of food inflation, right?
No. This is expectation of headline inflation.
Right. But the agent's expectation, right? So when he said this is important to me, of course it should show up on the left-hand side, right?
Yes.
So I was wondering whether I could view this as verification of his statement that it's important to him.
But we don't have anything on the right-hand side, about what food inflation was in that period. So what we're looking at primarily is whether the moment I say that food prices are very important to me, my expectations move more with news, quote unquote, that we don't have in there, or move more and more with perceptions that we have in there. But
got it. Yeah, right. Sorry. Yeah.
Everything should be about the aggregate.
Right. Right. I guess in my thinking, it would have to mean that the guy's already interpreting the current inflation that he perceives to be driven by those food prices, and then he's just
exactly. We're looking into that. Cool. We're looking into that.
Yeah. But by the way, that I found was a very cool conjecture that, of course, the high volatility stuff may be important, but in these people's perceptions, it also endows. They think that the effects are persistent, which is not what you would expect from a commodity price, for example.
Yeah.
Thank you.
Thank you.
All right, in the interest of time, we're gonna move on to the last presentation. It's gonna be me. Thank you. Let me share my screen. Is it viewable?
Yes.
Okay, excellent. So thank you for organizing this section, and thank you for all the presenters before me to stay on time. So this is a joint work with Bob King from Boston University, Managing Expectation in the New Keynesian Model. So this is a paper out of a research agenda that we're pursuing. So let me first have some background on this research agenda. So basically, as we know, in macro models, it is often the case that ex ante optimal policy is not optimal ex post. So we call that time inconsistency. So typically in the literature, people dealt with the issue by solving two solutions. One solution under full commitment, another solution which is time consistent. So we think that an implicit assumption of calculating these two solutions is that we think that policymakers' ability or inability to commit is known by the private sector. Okay. However, we think it is often not the case because the ability to commit is not directly observable, but has to be signaled in some costly way. So therefore, the research agenda is trying to ask, when a committed policymaker who has not yet gained the full trust from the private sector, what is the optimal policy to commit to? So in this particular paper, we try to answer this question using the following setup. So we're going to model a two type of policymaker. One can commit and the other cannot, but both type policymakers are optimizing. And we also have a private sector that does not observe the true type of the policymaker, but can learn over time by observing the policy outcomes. And also the private sector is forward-looking, informing expectations. So we apply this model to study optimal monetary policy in a new Keynesian model, and we find that the prediction of a model can shed light on understanding the US inflation experience. Okay. So let me be more specific in that. So here, this is a time series of the forecasting error collected by the professional forecaster of Philadelphia Fed. Okay, so when it is above 0, it means positive forecasting error. When it's below 0, it means negative forecasting error. And then the red lines are the average or smooth out forecasting error from this quarterly frequency data. So you can see that, interestingly, there seems to be a turning point around 9080, where before 9080, the forecasting error are consistently or persistently positive, and after 9080, they're persistently negative. So this observation is frequently quoted in the learning literature as supporting that agents are learning using misspecified model. But we are proposing a different argument. We say we could also interpret this as private sector are learning about central bank's type. So when the forecast error is positive, it is when the true type of policymaker or central bank is the one who cannot commit. So they try to constantly surprise the private sector with positive inflation surprise to gain output. And after 9080, the true type of the policymaker is the committed type. But the private sector do not know yet. So they constantly expected higher inflation than the central bank actually implements. However, when we're using this interpretation, we run into two questions. One is, suppose the pre-80s, the true type is the opportunist type that cannot commit. Why does it take 10 years for the private sector to figure out the policy maker cannot commit after observing positive inflation surprise for 10 years? Second, if we think after the 80s, the policymakers are the committed type, but both Volcker and also Greenspan are belonging to this category. But we know that inflation dynamics and output dynamics are very different under these two chairmen. So we wanted to understand why the inflation dynamics are so different, even when we're looking at the same type of policymaker. Okay. So what our model is able to shed light on understanding this phenomenon. So now, before we go on, I'm going to use a pedagogical model to connecting to the literature. Okay? So suppose agent has forward-looking expectations. And now let's looking at this very commonly used random regime switch model. So suppose there's two regimes. One is committed regime, one is discretionary regime. So in the committed regime, the policymaker is able to commit. In the discretionary regime, the policymaker cannot commit. So there is random regime switch with probability rho, you're going to stay in the same regime. With probability 1 minus rho, you can switch to the alternative regime. Now the important thing is when you have this random switching and the expectation forward looking, we know that when you're designing your committed policy at period T, how the period T plus 1 discretionary policy will matter because it enters in the expectation in period T. So you have to take care about how the next period a discretionary policymaker will do in your today's optimization. Similarly, when you think about what the T plus 1 discretionary type will do, it will depend on how T plus 2 both type of policymakers decision, because the T plus 2 policymaker decision will enters in the expectation in T plus 1 and therefore entering in the discretionary policy in T plus 1. So the takeaway message is when you have this type of model, a committed policymaker making decision T have to take account how his future policy commitments affecting the future discretionary policymaker decision. Okay. And so now coming back to our model. So in our model, we retain the forward-looking expectation assumptions, but we replace the random regime switch with incomplete information and learning. Okay. So here, the agent or private sector do not observe the intended policy of different type of policymaker. So instead, they're going to observe a signal of this intended policy. We call the signal pi, inflation. So by observing the signal, they're gonna attach some probability that the current policymaker is a commit type or the opportunistic type. And after they observe the signal, they're going to update their belief over time. So it is like a random region switch model, but with the switching probability time varying and depends on the history of inflation experience. Okay? But still, our previous takeaway message holds that when you're designing optimal policy in the committed regime, you have to take account how my future committed policy affecting the future discretionary policy and therefore affecting my current committed policy. So essentially, this is a dynamic game between two policymakers. One is able to commit, one cannot commit. And when they're playing this, they know that their policy is going to have a consequence in the private sector's expectation, and therefore it's payoff relevant. Okay. So what we do in this paper is we show that we can obtain the equilibrium of this dynamic game as a solution to a recursive optimization problem. So we're going to formulate this dynamic game as a principal agent problem, treating the committed policymaker as a principal and treating the opportunistic policymaker and private sector as agent. Then we're going to apply this recursive formulation a la Marcet and Merrimon so that we can solve everything one time as an optimization problem rather than a game. And it's a complicated optimization problem, so we develop an efficient algorithm to compute the solution. I'm not going to talk about in these short presentations. And then what we obtain is we obtain in equilibrium when the current policymaker is the opportunistic type, then we can actually qualitatively replicate the US experience in 70s and the 60s. In particular, we can generate some lengthy real stimulations with gradually rising actual and expected inflation. And along this period, the reputation of the central bank is going to erode, and eventually we will end up in a high inflation and low output stagflation stage. And also we show that if you conditional on the current policymaker is the committed type, the optimal committed policy will depend in a nonlinear fashion on the central bank's initial reputation for commitment. So basically, if you start with a poor initial reputation, the optimal inflation policy will be aggressive disinflationary policy. So we interpret that as describing the inflation dynamics under Paul Volcker, Volcker disinflation. But when the central bank starts with a fairly good initial reputation, then his optimal committed policy will be close to the standard solution under full commitment. So we view that as a proxy to the Greenspan's policy, right? So this is basically our model. So we have the committed type choose and follows through a policy plan that maximizes his lifetime utility. And we assume there's also a discretionary type or opportunistic type that chooses policy alpha at a period by period base. So in another way, there is another difference between the two types. The commit type is patient, and then the discretion type is impatient. And then the inflation outcome is a random outcome out of two intended policy. If the current policy is designed by the commit type, then this inflation will be the committed intended policy plus the IID observational noise. If the current central bank is the opportunistic type, then the inflation will be a opportunistic intended policy plus noise signal. And then the private sector will have this forward-looking new Keynesian Phillips curve. Okay, so this is the key to the dynamic. So within each period, this is the timeline. So we have a public observational shock that the current central bank leaves or stays. Okay, so after this public observational shock is realized, the cost push shock will also be realized, which is observable to everybody. And then the policymaker will choose his intended policy outcome, but it will be hidden from the private sector. And then based on this intended policy outcome, there will be a random inflation signal draw. And based on this based on this random signal, the private sector is going to form an forward-looking expectations. And finally, this forward-looking expectation is going to determine the output. So when the private sector update their belief on how likely the central bank is a committed type, he's using the standard Bayes rule. And when he forms expectations about next period inflation, he is using the rational expectations that with probability rho, next period, he will be facing a committed type. With the complementary probability, he's gonna face the opportunistic type. Okay, and we study this public perfect Bayesian equilibrium in our paper. Basically, we show in our paper that this equilibrium will be only based on the publicly observable history. So basically the history of the realized signal inflation and also the history of the cost push shock. And based on this public history, the committed type is going to choose his intended policy. The opportunist type is going to choose his intended policy. And then the private sector is going to form expectations. So in this equilibrium, we're going to require that the private sector's belief is consistent, and also both type, the committed type and the opportunist type, will be sequentially rational. Okay. So the important thing about the sequential rationality of the opportunistic type is he's going to choose his intended policy to maximize his current payoff. Okay, and why we call that opportunistic or discretionary? Because this type, he's going to take the private sector's expectation as given. So he doesn't think he has obligation that he can influence the expectation function. Okay? And so we can summarize the opportunist type's rationality condition using a Forsyth condition. Okay? And for the commit type's optimality, then we're going to solve an intertemporal problem subject to the two conditions. One is we require the private sector in forming rational expectations. Second, we're going to require that the opportunist type is going to satisfy his first order condition. Okay? So when the commit type is choosing expectations, he's going to know that the expectations is going to be affected by the current and the future policy actions by both type, and also the policy actions by the opportunist type has to satisfy an rationality condition. Okay. So when we formulate this problem in a recursive optimization problem, you can basically see that this is a very commonly used recursive optimization when we attach a Lagrangian multiplier to a forward-looking constraint under the Marcel-Meromon formulation. And what's special about this paper is the term in 8. So this is a term that is basically saying, let the principal, which is the commit type, to choose his own action and choose the agent action alpha, which is the opportunistic type. But agent action alpha has to satisfy an incentive compatibility constraint, which is summarized in expression 8. Okay. So then we have some way to tell you how to solve this thing in an efficient way, and I'm going to skip this. But let me try to take you through the equilibrium outcome. So we adopt a calibration that is consistent with some micro foundation of the payoff function we assume in the model. So let me first take you through what would happen if the true type of the policymaker is opportunistic type. So this trying to answer why it takes so long pre-1980 that agent is going to figure out they're facing an opportunistic type. So we argue that it is because in the 60s, the central bank in the United States has a fairly good reputation for commitment. So people think very highly that the central bank is going to deliver whatever he promised in his policy announcement. So you can see that when the central bank has a good initial reputation, so we start with 80% chance he's a committed type. So his true choice of inflation is going to be fairly low at the beginning and gradually increasing and eventually run up to the inflation bias. Okay. And you can see with this inflation, he's able to sustain a fairly good output gap until his reputation deteriorate, and then the economy falls back to the stagflation, where you have high inflation and low output. Okay. So the question is why it takes so long for the reputation to deplete. So the answer to that is when the central bank has high initial reputation, even for the optimist type, he does not need a very high inflation to obtain a good output gap because the expectation of inflation is well anchored due to high reputation. Okay? So it is harder to distinguish an optimist type from a committed type because they will implement very similar policies. But when the reputation gets lower and lower, this is hard to sustain, but the next page is what would happen if it is a committed type is in charge. Okay? So even now we have a lower likelihood that the private sector is facing a committed type, but if it were the committed type in charge, the committed type will implement a very aggressive disinflation policy. So even at the stage where the reputation is at the intermediate stage, the expected inflation is still well anchored because the perceived committed policy will be very negative. Okay? So that's why we can sustain a fairly long time of high output gap and without people figure out they're facing the optimist type. Second, let me also take you to what happens if the true type of policymaker is the committed type. So here, when the true type of policymaker committed type, his optimal committed policy will be very sensitive to the initial reputation, okay, in the following sense. So here, the black line is the optimal committed policy when the central bank has full commitment power. So people believe 100% they're facing a committed type. So you can see we have this very standard startup inflation. So you start with a high inflation and you promise disinflation along the way until it reaches zero in the long run. Along the way, you're going to have inflation, you're going to have an output real stimulation, okay? Because along this disinflation, the expectation is always below the actual inflation. So we use this black line as a benchmark. And the blue lines are the optimal inflation when the initial reputation is fairly high. So 0.8 for the triangle and 0.5 for the diamond. You can see that when the initial reputation is fairly high, then this optimal committed policy is closer to the optimal committed policy under full commitment. So you don't deviate much. So we interpret this is what happens during the Greenspan. Okay? And the red lines are the optimal committed policy when the central bank start with fairly low initial reputation. Okay? So the triangle represent, it started with reputation equal to 20%, and then the cross is the initial reputation equal to 10%. And you can see these red lines are very, very different from the blue lines. Okay? And they are represented by a fairly aggressive disinflation policy to begin with very high output loss. But the positive side of this policy is you're going to get fairly rapid learning because people know very fast that it is a committed policymaker is in place, because otherwise this disinflation policy will not be implemented. Okay, so we interpret this as a Volcker disinflation. Okay, so our interpretation about U.S. inflation experience is when Paul Volcker took place, he started with a fairly low initial reputation. So he has to implement this disinflation dynamics in order to gain reputation rapidly over his tenure. But at the end of the tenure, actually he built up his reputation, and that is what the Greenspan inherit. So Greenspan start with a fairly high initial reputation. That's why he is able to follow a fairly standard textbook for commitment solution and then generating this great moderation period. And so here is just some backup slide that tells you what happens would be the opportunistic policy that private sector would perceive. So you can also see that if the central bank start with a fairly good reputation, the opportunistic policy will not be perceived very high. But if the central bank start with a poor reputation, then the perceived opportunistic policy will be pretty high. Okay. All right, so this is what we have. So we basically provide a method to compute the optimal committed and opportunistic policy when the policymaker has imperfect credibility. On top of that, we assume that the private sector is learning about the policymaker's type, and also they are forward-looking agent. So our model is able to generate the equilibrium dynamics under opportunist type to be consistent with the US inflation experience in the 60s and 70s. In particular, it can explain why there were some lengthy real stimulations and a gradual rising actual and expected inflation. And the reason why the learning is so slow in the 60s and 70s is exactly because we find some nonlinear dependence of optimal or committed policy on the initial reputation. So if you start with good reputation, okay, then the optimal committed policy will be closer to the standard solution under full commitment, and the optimal opportunistic policy will not be too different from the optimal committed policy. So it's very hard to learn. If you start with a poor initial reputation, then the optimal committed policy would be anti-inflationary with real output cost. And here it is fairly easy for people to figure out whether it is a committed policy maker in place or the optimistic policy maker is in place. Okay, so that's all I have. So now I'm open to questions. I have 5 minutes left, I believe.
I mean, maybe if you like, first a small clarifying question. So in this setup, there is no actual switching anymore, right? The idea is you set them off with an initial condition, and then it's basically how long does it take for people to learn who's truly in charge. There's no, and
so just to clarify on that. So in this presentation, I don't have any switch. But in the paper, we allow, you know, there is a possibility to have a
right, yes,
on the policymaker next period.
Okay, so basically in all these trajectory that you have plotted, I mean, basically to the extent that the further out they go, the less likely it is to be staying on that path, right?
Yeah. So with the time series you saw, it is conditional on there is no replacement realized. But
Right.
when the agent are forming expectations, they take into account
Yep.
some possibility that next period they're going to be a new policymaker.
Right. Maybe with that information in the back of our mind, I was struck there were these pictures when the discretionary guy was in charge, and I believe they showed what seemed to be almost like a permanent effect on the output gap. I mean, given that finite horizon.
You mean?
Yeah.
What do you mean? Like permanent gap?
I mean, right, the output gap starts at a high level and then declines, and I guess it's supposed to stay there. How should I think of that? Is it more like, well, there was this because people believed in the commitment guy being in charge, that was initially a boost to the output gap, or?
Oh, here. So you mean why it stays up for such a long period?
Well, here, well, yeah. Why it then comes down for like almost eternally? I mean, so it's basically the initial condition is actually a deviation from the long run, or?
Right. Yes. Yes. So so you mean here? So basically, what happens is the true type is optimistic. Okay, but people attach 80% chance the true type is committed. So this, in the sense, they have high initial reputation. So if you look at here, with this expectation, then the expected inflation is fairly low. Okay.
Okay.
And
they
so
get away
with a moderate realized inflation, you can generate this output gap. Okay. But when you have a lower and lower reputation, people attach higher and higher weight on this optimistic inflation, right? But it gets compensated by you have a very negative committed policy. So this negative committed policy is the one that still hold expected inflation down, given you have lost some of your reputation capital. So that's why over the entire period, you're able to, as an optimistic type, to sustain a positive output gap, even if your reputation was not as good as before.
Okay, yeah, got it. Thank you. So the long run is actually the zero, right? Yes, okay.
Yeah, so the long run, it would be zero, yeah.
Thank you.
Okay, I believe we're almost done. If there's no more questions, so maybe then let's mark the end of the session, Inflation Expectations, and thank you for watching, and we will see you in Q&A.
Thank you for sharing, Yang.
Thank you.
Thank you.